Hi, this question is taken from Practice Exam 2022 about the circular motion in which you see an amusement park ride consists of a very large wheel having a radius r, and this wheel is moving with a constant speed v. So which means that all at every point the speed is v, and this is the tangential velocity, which means that this velocity is changing just due to its direction, not due to its magnitude. So even at that place also the velocity is v because it's constant speed. Now the point a and d are the highest and the lowest points respectively. So if a person is sitting inside this in car, so the force, the weight of the person is the force of gravity Fg, and so as the seat passes the point A, the seat exerts a normal force of 0.8 Fg, means 80% of speed, 80% of the weight of the person. So this is the center of the circular path, and let's say that center is this point. So this is a force of gravity of that person, Fg. That must be the net force must be downward. So that's why in order to execute the circular motion, so the upward force is 0.80 Fg, right? Whereas the speed of this is right now is v. Okay, according to this diagram, just for an example. So, according to the question, what will be the normal force exerted when it will be passing from the lowest point, that is point D, exactly at that point? Now, the normal force at that point I have already shown you in the diagram is 0.80 Fg, okay, which is less than the force of gravity. But at the point D, since the center relative to that point is at this position, this is a center of the circle, right? And the radius is big R. Now remember, the net force must be towards the center, that is our centripetal force. So the net force, the sum of all forces in, and this is provided by the two forces. The one force is the normal force that must be always more than the force of gravity, right? So this is the force of gravity. Okay, so how many times it is equal to the force of gravity? Obviously it cannot be less than force of gravity. So that's why, and even it cannot be C, option C, because in that case, if the option C would be correct, then the net force will be zero, which is not possible because this is a circular motion. So it is right answer is D. But if you stick with the video, I can quickly show you how is it. So let's start from the point A, okay? Because I will try to find out the speed. So at the point A, at the highest position, the net force is the force of gravity minus 0.80 Fg, that is providing the centripetal force, right? So it is equals to 0.20 times mg is equals to mv square over r, right? And r is a radius of this wheel. Okay, so m and m is cancelled out, so you got the equation of v square from here, and that is 0.20 big r g. Okay, now we are proceeding towards the point D, okay, and we will write the normal force minus force of gravity is equals to mv square over r, right? Since they said in a question it is moving with a constant speed, so you can plug the value here, and the normal force is, and mg is equals to m over r. Okay, now I'm going to put the value of v square, which is equals to 0.20 rg. Okay, and normal force has become equals to, you can cancel this r with this r, right? And it is equal to 0.20 r g, sorry, mg. So finally, normal force is equals to, if you add mg on both sides, so it would become 1.20 mg, which means that 1.20 times the actual weight of the person. It means at the lowest point, the wheel is exerting actually more force than the force of gravity than this mg. So it must be equals to 1.20 fg. So that is option D.